Okay, right. Bismillahirrahmanirrahim. Okay, let's start. Topic 3, acid and bases and ionic equilibria. Okay, all right. So this topic 3, as you can see, the topic ataupun the title of the topic itself is very obvious. It involves acids and bases. That means the reactant and product. The reactant lah, I would say reactant involve acids and bases. Okay, and some of the reaction also can produce acid and bases. Okay, and the ionic equilibria. Okay, the word equilibria means that it involves equilibrium. Okay, so when we have equilibrium, that means we may have KC, remember? But this one, in topic 3, we have KA, KB, okay, KA and KB. So topic 3 is like, I would say the application of topic 2 sebenarnya. If you have problem related to topic 2, you might have problem for topic 3. Okay, alright. So these are the content of topic 3. As you can see, looks like the subtopic that we have in this topic is, I would say, quite moderate. Okay, dia taklah banyak, similar to topic 2 last time. We have around this the number of subtopic is around 5 to 6 jugalah. Okay, so dia lebih kurang saja. It's just that the content for each of the subtopic tu banyak compared to topic 2 last time, topic 2 and topic 1. Okay, theories of acid and bases, we have a lot in here. Strength of acid and bases, banyak. Acidity and basicity measurement. Okay, this is how we measure the acid and base, the acidity and basicity measurement. Okay, and then after that we have salt hydrolysis. We know that when acid react with base, okay, the reaction will produce salt. Okay, alright. Even the salt has its own pH. In case kalau tak tahu, salt ada pH dia sendiri. Does not necessarily means when we are talking about salt, the pH will be 7. Not necessarily. Okay, we have acidic salt, we have basic salts. And then we have acid-base titration. This is the application of acid-base up here. Okay, where these two are reacted. And then the process is what we call titration. And last but not least is buffer. So what is buffer? Buffer is when, yalah buffering, macam loading. Buffer is when we have salt and acid. Okay, what happen if we have salt and the acid ataupun salt and the base? Normally we would react acid dengan base, react together. But in some cases we may have acid and salt. When these two are reacted, we will produce a buffer solution. Okay, so this one will be covered later. So this one may be new to you guys. Salt hydrolysis is also new. Strength of acid and bases is also, you have the concept already. It's just that this is extension to that. Okay, strength of acid, the kekuatan acid tu, and this is how we measure the acid and base based on pH. Okay, you tahu kan pH kan? Tapi this is the part that you have to calculate the pH of the acid and base. Okay. Right, so let's start with 3.1, theories of acid and bases. We have theories, okay guys, theories for acid and bases. So as you can see, we have only 2 learning objectives. You have to define the acid and base according to Arrhenius, Bronsted, and Lewis theories. As you can see, we have 3 theories, okay, for acid and bases in SPM. Okay, during your SPM time. You don't have this. I believe that you were not exposed to any of these theories, but the one that you've learned, I believe, come from Arrhenius, not Bronsted-Lowry, not Lewis, but Arrhenius. Okay, it's just that dia tak specify lah. Okay, this is based on Arrhenius. I'm not sure whether you guys are been introduced to that. Tapi masa zaman saya, no. tak ada introduction to this Arrhenius. We just know that acid produce H plus, base produce OH minus. That is all. Okay. So in Asasi, I mean for foundations syllabus, we have the theories, and then I identify the conjugate acid base pair according to Bronsted-Lowry. The most famous one that usually asked in the exam is from Bronsted-Lowry. Okay, famous. Tak semestinya yang lain tu tak keluar. Okay, general properties. Okay, everybody knows about this. Acid has taste, sour taste, and then it has the ability to change the color of wet blue litmus paper to red. So the what do we call that? The litmus must be wet first. Okay, it is a wet litmus paper. Then only it can exhibit the characteristic of acid. Kalau dia tak basah, dia tak boleh nak tunjukkan dia ni. Tapi after all, acid is already, I mean, aqueous solution kan. So it change the wet litmus paper, the blue litmus paper to red, and the pH is less than 7. Acid has the ability to react with metal. On the other hand, bases taste bitter and slippery. Okay, change color of wet red litmus paper to blue, and the pH is more than 7. Do not react with metal. Okay, bases do not react with metal, but acid does. But acids do react with metal. Okay, alright. So these are the pH of some familiar aqueous solution that we may use in our daily life. Cuba tengok. 1 molar of HCl. Okay, jangan ingat pH kosong tu tak ada value kosong tu maksudnya yang paling acidic. Okay, and then selalu kita start dengan 1 kan. Kita ada 0.5, 0.7, ada. Okay, stomach acid. It's around 1 to 3. Lemon juice kita is acidic 2.2 and 2.4. Vinegar, beer is acidic. Okay, unpolluted rainwater. Unpolluted, dia memang acidic. So imagine kalau dia polluted, it will go down to around 3 here. This is unpolluted, 5.6. Kalau polluted, it will go down to 3. Maksudnya dia become more acidic lah. So it can corrode the car, metals, bangunan, buildings and whatnot. And then 7 is neutral. Even our blood, kita tengok blood is 7.4. Is slightly basic. Seawater is basic also, is around 7 to 8.3. Our detergent, okay, detergent solution is around 10. Milk of magnesia, this is the one that we use if we have gastric, is 10.5. Okay, kita punya stomach acid is produced excessively, so it may cause, kalau worst case scenario, it cause ulcer to your stomach, okay, to your perut. This is one of the solution lah to that. It is called milk of magnesia. We know that magnesium is basic kan. Magnesium group 2, dia basic kan. So that is why we use this. Magnesium is one of the dia punya substance used in this tablet, ataupun itulah, saya tak pernah ada experience makan gastric tapi saya tak tahu, tapi saya tahu baca based on they use milk of magnesia to treat gastric. Okay, household ammonia. So we've learned about Haber just now. Ammonia is basic. Okay, so sometimes the soil, tanah kita tu is acidic, so we need to neutralize the soil, ataupun we have to make it less acidic by adding fertilizers. So most of the time fertilizers are basic, because tanah tu dia akan jadi acidic. So it's one of the uses is to neutralize the acidic pH of soil. Okay, alright. And then we have lye. Lye ni apa? Is it dye? Is it the same as dye? And then we have sodium hydroxide. Okay, alright. Okay, let's start with Arrhenius, guys. Arrhenius theory of acids and bases This is the earliest acid-base definition. Yang paling tua lah, senang cerita. Okay, Arrhenius is a scientist. This is the earliest acid-base definition which classify the substance in terms of their behavior in water. Okay, alright, so Arrhenius acid based on Arrhenius is a substance that when dissolved in water increases the concentration of hydronium ion. Okay, alright, so it will, katakanlah kan, HCl, okay, in water, H2O, it will dissociate to produce, you akan buat macam ni. Kalau dissociation of HCl, you akan tend to buat begini. This is with respect to HCl punya dissociation. Tapi sebenarnya H plus ni, dia tak boleh stand alone. When you dissolve HCl in water kan, yes, this is how the dissociation takes place. Tapi H plus will not stand alone macam ni because it is unstable. They're very reactive. H plus is very reactive. Okay, so what happens is that it will combine dengan water. It will combine with water to produce hydronium ion. So normally bila kita buat reaction HCl dissolved in water, it will be like this. Dia dissociate kan, dia produce H plus, and then this H plus we combine with H2O, producing H3O plus, Cl minus. This is what it meant by increases the concentration of hydronium ion. Okay, because why? Like I said, lagi sekali saya ulang, HCl betul dia akan dissociate to produce H plus and Cl minus. It's just that bila dia in water, H plus cannot present in this form, in this H plus form, because they're unstable. It is very reactive. It tend to react with substance yang ada around it, okay, around them. So H plus will react with H2O, okay, has higher tendency to react with H2O and produce H3O plus. That's why when you write an equation, you know that HCl is dissolved in water. So this is how you should be writing it. It shows the real reaction in what actually happened in the aqueous solution. Okay, so it increases the concentration of hydronium ion. On the other hand, Arrhenius base, when dissolved in water, increases the concentration of hydroxide ion. Hydroxide, OH minus is not a problem. OH dia tak akan react dengan siapa-siapa. H plus here. Okay, so when you have sodium hydroxide, usually to prevent the dissociation of sodium hydroxide, kita just buat macam ni je. H2O below the arrow, and then we just have sodium plus and OH minus. This is not a problem. It will not combine with H plus ke apa because it's already stable. But H plus not. Dia tak. Dia akan combine H2O to produce H3O plus. Okay, alright. So this is based on Arrhenius lah. Arrhenius kata dia mesti behavior dia in water. Behavior in water. Then only it can shows the characteristic. If not in water, dia tak boleh tunjuk. This is based on Arrhenius. Okay. So the Arrhenius, the thing about Arrhenius is that the concept is very limited. Okay, the concept is limited. This is this disadvantage of Arrhenius. Okay, it considers acid-base reaction only in aqueous solution sahaja. Okay, what about other substance that does not react with water, does not produce OH minus in water, but still has the characteristic of base? Contohnya, ammonia just now. Okay, ammonia, it will not produce OH minus in water. Okay, tapi dia bersifat basic. Tapi kalau based on Arrhenius just now, the problem about Arrhenius, dia kata it is base if it produce OH minus in water. Okay, so how about ammonia? Ammonia tak produce OH minus in water, but it is still base. Okay, alright, so that is the limitation of Arrhenius theory. It's not wrong, it's just that dia punya coverage is very limited lah. Okay, so it need to be expanded further. So This is Arrhenius acid-base reaction. So NaOH react with HCl to produce NaCl and H2O. So turns out these two are Arrhenius base and also Arrhenius acid. These two can be reacted together to produce an acid-base reaction. Okay. So problem tadi again sambung. It limits bases to compound that contain the hydroxide ion saja, like sodium hydroxide. Sodium hydroxide has OH minus kan. So no wonder lah it can produce OH minus. So how about other substance that has no OH minus? Kan, takkanlah dia tak ada OH minus, dia bukan base. So dia punya privilege tu dah kena revoke. So Arrhenius lemah lah dengan situ, because such as ammonia, sodium carbonate, sodium oxide do not satisfy Arrhenius definition. That's the problem related to Arrhenius. Okay, and it also limits the acid that contain the hydrogen ion juga. Same goes to acid. Okay, dia hanya cover acid yang when dissolved in water produce H+. How about CO2? Okay, we know that CO2 is acidic, right? When CO2 react with water, it produce carbonic acid. Dia tak produce H+, it produce carbonic acid H2CO3. Same goes to SO3 and SO2. Okay, dia tak produce H+, like what Arrhenius said, tapi it has the characteristic of acid. Okay, so itulah limitation of acid and Arrhenius. Then there comes Bronsted-Lowry conjugate acid-base pair. Dia ni dua orang We have Bronsted and we also have Lowry. They come after Arrhenius. Okay, diorang ni kawan-kawan je. Okay, dia macam di geng-geng dia. Arrhenius kawan dengan Bronsted, kawan dengan Lowry. Okay, member je pun. Okay, tengok ada yang saintis punya gambar yang tahun zaman dulu-dulu kan. Member duduk sebelah je. Einstein, lepas tu ada Arrhenius, ada Arrhenius, and then ada Louis. Duduk side by side je. Okay. Okay, then later we have Bronsted-Lowry conjugate acid-base pair. This is an extension of Arrhenius. Okay, dia punya coverage dia little bit bigger compared to expanded sikit compared to Arrhenius. Okay, so based on Bronsted-Lowry conjugate Bronsted-Lowry concept provide broader definition of acid and bases, thus further develop the Arrhenius theory. Further develop, dia tak kata Arrhenius salah. It's just that they further develop. Arrhenius very limited. Okay. An acid-base reaction involve the transfer of proton ataupun H+. Proton means H+. Okay. Acid base based on Bronsted-Lowry is described in terms of the transfer of proton. Okay, so let's look at an example here. We have H3O plus and we have NH3. Okay, it is called acid ataupun Bronsted-Lowry acid if the species donate the proton, ataupun it is called a proton donor. Then dia adalah acid. Okay, logically speaking, in order to become a proton donor means you need to have an extra proton lah. Betul tak? Baru you boleh donate. You nak donate duit, you kena ada extra duit. Logiknya lah, logiknya. You ada extra, then baru you boleh donate normally. Okay. So, if you are talking about proton donor, that means the substance need to have extra proton, then only it can become the donor. Okay, this is for acid, the proton donor, the species donating a proton. Base on the other hand would be the opposite of proton donor lah. Dah seorang donate, the other one should be accepting ataupun acceptor. Okay, the species accepting a proton it is a proton acceptor. Cuba kita tengok, okay, how do we identify based on this reaction? Okay, how do we identify whether dia adalah donor, is it an acid ataupun whether it is an acid or a base? Okay, alright, so we have to look at the reaction as a whole. You kena tengok before and after dia in order for you to identify which one is the donor, which one is acceptor. Okay, alright. Tak kisahlah nak start mana-mana. Okay, let's start from H3O+. Okay. Before, it has 3 hydrogen. And then when dia after means after the reaction, they become H2O. Maksudnya dia lost 1 proton there. Nampak tak? Lost 1 proton. So maksudnya here dekat depan ni, dia adalah donor. Okay, sebab dia lost before and after dia. Before dia ada extra proton, after dia become less 1 proton. Okay, that means it is a donor. This one, NH3, before it has 3 proton ataupun 3 hydrogen, and after when the reaction takes place, dia become dia ada extra proton there. So obviously it accepts a proton. So NH3 is a proton acceptor. That is all. As simple as that. Okay, you identify macam tu. Okay, so this is the H3O plus is being transferred. Sorry, the H plus is being transferred from H3O plus to NH3. Okay, alright. A compound that acts as both Bronsted-Lowry acid and base together is called amphoteric. Ada compound yang has the ability sebagai donor and also acceptor depending on the reaction. Okay, kalau dia ada untuk reaction ni dia jadi donor, untuk reaction ni dia jadi acceptor. That is what we call amphoteric. For example, water. Water is amphoteric. Okay, sometimes it can become acid, sometimes it can also become base. Okay. Alright, so we have identified the Bronsted acid and base just now. Okay, how about the conjugate? What do you mean by conjugate, guys? Substances in the acid-base reaction that differ by the gain or loss of proton are called a conjugate acid-base pair. Okay, that differ maksudnya, okay, HA just now, HA becoming A minus. So dia punya perbezaan HA to A ni, dia hanya beza 1 proton. Okay, alright, so normally dia punya pair dia, kalau this is acid, dia punya pair will be conjugate lah. Okay, alright. Dia punya conjugate tu, you kena be careful. Okay guys. Dia bukan Bronsted acid, this is conjugate acid. No, dia conjugate base. Kenapa? Okay, try to reverse this reaction. Try to reverse this reaction. Let's say, A minus becoming HA, guys. A minus becoming HA. So, from A minus, dia accept proton, dia jadi HA. Betul tak? So, that is what we call base, betul tak? Acceptor. A minus is an acceptor. So that's why nama dia base dekat situ. This is if we were to reverse the reaction. Kalau kita forward reaction from HA to A, this is an acid. HA is an acid. Tapi kalau kita reverse from A minus to Bronsted acid, this A minus is a base. Sebab dia accepts. Okay, alright, same goes to H2O. If from H2O to H3O+, so H2O ada 2 hydrogen. Now, bila dia jadi H2O+, dia ada extra hydrogen. Betul tak, guys? So that H2O is a base. Okay, so these two are they are different in terms of the number of protons. So this is what we call conjugate. Tapi this is conjugate acid. Kenapa? If we were to reverse this one from H3O plus to H2O, tadi mula-mula ada 3, now jadi 2. So itu perangai donor kan? Mula-mula dia ada 3, now dia jadi 2. Donor siapa? Acid. Okay, that's why dia conjugate acid. Alright, okay, nak senang cerita, lepas dia habis reaction, terus dia tambah conjugate guys tu. Lepas the arrow, you have to add in conjugate. Okay, it's just that you kalau nak malah nak fikir-fikir kan, nak hafal je terus. Okay, kalau this is acid, dia punya pair dia kena base. Don't forget the conjugate because it is after the arrow. Okay, acid, pair dia base. Base, pair dia acid. This one is Bronsted, this is the conjugate acid. Okay. Alright, another example. Okay, so this is base. kenapa dia base, dia proton acceptor kan. Initially dia without hydrogen, without proton, and then after the reaction it accepts proton. That's why dia base. This is proton acceptor. Okay, same goes to reverse. Kalau you reverse kan, initially dia ada satu proton. And then bila dia jadi, after reaction dia jadi without the proton. So BH plus is an acid sebenarnya. Okay, cumanya dia duduk after the reaction. So kita add in conjugate. Tengok water. Okay, this time around, water behave as an acid. Sebab dia depends, water ni dia depends dengan siapa dia combine. Okay, alright, just now, earlier on, we have water as a base. This one, we have water as acid for the second reaction. So this is what we call amphoteric characteristic. Okay, alright. It can act either as a base or as an acid. Okay, make sure that you have the pairing correct. Okay, you have the correct pairing. Not only you have to list down, you have to pair. Kena buat ni. Ni you kena pair kan. Sometimes student Bronsted acid, conjugate acid. Dia pair kan macam tu. Salah. Okay, so you have to pair kan before and after dia. This one, kena buat arrow ni. And then kena pairing nama yang betul. Okay. Example, consider the following acid-base reaction. Identify the acid base and its conjugate pair. Okay guys, H3O+. This one, is it an acid or is it a base, guys? Nak kena identify acid base and dia punya conjugate pair. Like this one just now. Okay, you have to write down below each substance and then you have to pair them. Okay, alright, so H3O+, is it an acid or is it a base?
Acid.
Acid.
Acid. How about NH3? Acid base lah kan. Acid pula, acid base. Okay, okay, H3O+ becoming H2O. So this one will be how about H2O?
Conjugate.
Base.
Conjugate base. You need to have conjugate, okay? Conjugate base. This one is conjugate acid. Okay, don't forget to pair them. Jangan salah pair pula ini markah 2 markah. So jangan hilang Ini kira markah free lah. Kalau soalan keluar macam ni. Okay, alright. So B pun sama lah. Boring lah. Buat sendiri ni. Try buat. Buat soalan ni. Buat semua soalan ni. Kita discuss. I give you like 3 minutes for this question. And then we'll proceed to the discussion. Cuba buat. Please token. Okay, are you done, guys?
Yes, madam.
Yes, madam.
Yes.
Okay, jom check jawapan. Check sendirilah jawapan Malas saya nak go through nak go through satu-satu. The concept is still the same. Just check your answer with mine, okay? Right, check. Yeah. Tak ada pairing. Do the pairing, guys. Do the apa? The connection line tu. Okay? So these are the acid base and its conjugate pairs. Make sure that you got all correct for all of them. Okay, all right, so let's move on. We have one more checkpoint. Write the conjugate acid or conjugate base for the following species. Ta-da! So this is extra sikit. Okay, all right. Normally you'll be given this type of question, but the question can also ask you to write to identify the conjugate acid or conjugate base. Okay, but you are only given one substance ataupun one species only. You have to predict. Okay, you have to predict the conjugate of the given species. Kena predict sendiri. Boleh? Okay, alright. Okay, let's do this together. CO3 2-. So as you can see, do we have any proton attached to this one? We don't. Okay, it does not have any proton attached to it, so obviously it would be base lah. It will never be acid because dia tak ada extra proton dekat situ. Okay, tak ada satu pun. So this one definitely will be base, Bronsted base lah. Okay, alright. So dia dengan apa? Right, the conjugate acid or conjugate base. Okay, let's just try dengan water lah, okay? Alright, but what our concern is on this one. Kita nak tahu if this is base, that means the conjugate should be conjugate acid, right? Okay. Tak ada ni pun tak apa. So imagine if you have conjugate acid for this one, it would be kalau dengan water kan. So it will accept proton from water, right? Sebab dia adalah acceptor. So they become macam ini. But be careful, okay? This is no longer 2 minus. No, this should be minus. Because 2 minus, you dah accept proton. Proton kan plus 1. So plus 1 plus 2 minus will be negative 1 only. Jangan 2 minus pula. Okay? So kan dah belajar chemistry daripada awal dulu. So there's something change lah. Obviously, dia punya what we call that charge will also change. Okay, kalau kita katakanlah we have water also, this one will become OH minus because it lost one of its proton to CO3, 2 minus. So this is what we call conjugate, acid. Okay, right. So this is the conjugate. How about B? H2PO4 minus. H2PO4 minus. Okay, ada dua probability guys. Sebab dia ada proton dekat sini. Okay, dia ada proton dekat situ. H2PO4 minus, if it accept proton, that means dia behave sebagai acceptor, dia akan jadi H3PO4. Familiar kan this one? This one zero lah. If it accept proton. Kalaulah dia behave sebagai acid. Another one, if dia lost its proton, dia akan jadi HPO4 2 minus dekat situ. Tada! Dengan water lah. Paling senang water lah. Okay, tapi kita nak predict je kan. Kita nak predict. Okay, once we once we have identified that the species has proton, so kena be careful. Okay. Dia ni most likely boleh jadi acid ni sebab after all dia ada dua pula. Sudah. Okay, most likely dia boleh jadi acid ataupun acid. Acid lah sebab dia boleh jadi acid sebab dia ada proton. Okay, tapi in this case dia ada dua dekat situ. Dia ada dua. So dia ada dua probabilities. Either they accept one proton, that means dia jadi base. In this case dia jadi base lah because dia accept. Dia terima satu proton, dia jadi H3PO5. If they remove one of his proton, dia lost, dia jadi satu dekat sini. So this is an acid. Okay, dia ada dua probability. But be careful, okay. This is 2 minus sebab dia dah hilang the H. Okay, alright. Tapi answer is only this one. HPO4 2 minus. Okay, alright. Sebenarnya memanglah our expectation just now dia boleh dua-dua. Tapi sebenarnya in reality yang lebih mudah to form is this one. This one is easier to form compared to this one. This is possible. It's just that it is easier to form this second reaction compared to first reaction. Okay. Alright, so that's why the answer is H2PO4 2 minus. Right? Okay, this is conjugate base. So this is acid, Bronsted acid, this is base. So pairing dia acid lah. This one acid, pairing dia base. This is a conjugate. Don't forget the conjugate, okay guys? Gua apa dah? Ayu, 2 minit lagi. Okay, alright. Very quickly, what is last but not least is Lewis theory of acid and bases. Lewis is the same Lewis yang we have learned so far. Lewis yang last time is the same Pakcik Lewis. Okay, so we have Lewis acid and Lewis base. So it is opposite to Bronsted-Lowry just now. Lewis is more on electron. Remember, dia buat Lewis structure, electron dot symbol kan. More on the electron punya part. Yes, this time around pun dia electron juga. But based on Lewis, a species that accept acid is the species that accept electron. The opposite to Bronsted just now. Kalau acid, they accept dia donate proton. Dia bagi proton. But as Lewis acid, dia accepts electron. Yelah, Bronsted tadi, dia kaya dengan proton tapi dia miskin dengan elektron. So, that's why Lewis acid, it will accept the electron pair from another species. So, Lewis acid is an electron acceptor. Kalau base, donor lah. Electron donor. Maksudnya dia kaya dengan elektron. Lewis base, dia rich in electron. Example of Lewis acid, orang-orang yang miskin dengan elektron lah. Sebab dia kan accept electron. Okay, it will accept the electron. So, those yang miskin dengan elektron. Siapa? BF3. Boron, remember? Electron deficient. CO2. Sebab dia tak ada extra elektron, dia tak ada lone pair. Okay, orang-orang yang ada lone pair tu antara orang-orang yang kaya lah, kaya dengan elektron. SO2, SO3 yang ada double bond, normally dia adalah acceptor. Okay, electron acceptor. Sorry kita ada proton acceptor dengan electron acceptor. You kena specify which one. Okay, on the other hand, Lewis base orang-orang yang kaya dengan elektron. NH3, because nitrogen has one lone pair electron. PCl3 as well. P, phosphorus has one lone pair. Cn minus, because of the negative charge. Negative represent extra electron. OH minus is also representing more electron. That means it has more electron, therefore it can become a donor. Okay, alright, so this is how it looks. This is the reaction involving Lewis acid and Lewis base. So as I said just now, boron, okay, is an electron deficient species. Therefore, it is a Lewis acid. Ammonia, on nitrogen we have one lone pair, so it is a Lewis base. So basically, it will transfer. It will form a bond. So this is what we call dative bond last time, coordinate bond, because in order to form this bond, okay, a pair of electrons from nitrogen will be donated to boron, and the bond of what we call dative bond is formed. Tapi kita tak mau tahu yang produk, you just need to know how to draw it lah. Tapi you have to identify siapa acid, siapa base. Okay. Okay, like I said, molecule, macam mana nak identify, nak recognize the Lewis acid and base. Macam BF3 tadi lah, with vacant valence orbital. Maksudnya it has lack of electron. Macam mana nak tahu dia lack of electron? Dia ada valence electron yang kosong, macam BF3 ni. It has a vacant 2p orbital capable of accepting an electron pair. Maksudnya it has vacant valence orbital, therefore it can accept the electron from another species, and that electron will be placed in that vacant orbitals. Okay, and then secondly, a molecule will delocalize pi electron involving two atoms with different electronegativities involving oxygen. Like I said just now, pi maksudnya dia ada double bond or triple bond. So CO2 we have double bond, right? So dia adalah characteristic of Lewis acid. And then a metal cation, obviously, okay, orang-orang yang miskin dengan elektron, orang-orang yang positive charge ion, okay, alright. So Lewis base possess a non-bonding pair, maksudnya it has lone pair. So orang yang kaya dengan elektron adalah orang-orang yang ada lone pair, and then yang possess the negative charge ion, nak menunjukkan kekayaan dia tu, dia tunjuk dia ada negative charge. And then what else? Anions are better Lewis bases than neutral atom or molecules. Okay, let's say we have nitrogen, but this one nitrogen with negative charge. Which one is better? Which one is a better Lewis base? Anion lah. Lagi kaya dia dengan elektron tu, lagi bagus Lewis base. Okay, right. Generally, the more electronegative an atom, the less willing it is to be a Lewis base. Okay, maksudnya lagi negatif, dia kata kat sini, the more electronegative an atom, the less willing it is to be a Lewis base. Contohnya, oxygen kan is more electronegative than sulfur, right? Across the period kan? Across the period, supposedly the electronegativity increases. Okay, so based on this statement, the more electronegative the atom is, the less it is willing to become a Lewis base. Dia tak nak jadi Lewis base. Okay, so oxygen dengan sulfur, sulfur is more willing lah, more willing as in lebih bersedia to become Lewis base. These are the characteristic yang you kena be careful in case keluar objektif. Okay, objektif ingat 2 markah Okay, done. And summary. So make sure that you know how to differentiate between these three. Arrhenius mesti tunjuk behavior in water. They produce H plus or H minus. Bronsted-Lowry is in terms of proton transfer. Lewis is in terms of electron transfer. See? Inilah yang saya cakap. Dia geng-geng je. This is Arrhenius. This is Bronsted. This is Lowry. This is Lewis. Pakcik Lewis kita. Okay? So identify the Lewis acid and Lewis bases in the following reaction. So AlCl3, kalau tak ingat yang ni apa, maybe you can go for this, the second species first. Oh, Cl minus. You have minus there. That means you have extra electron. This is Lewis base. If this is Lewis base, that means this should be Lewis acid lah. And then after all, remember bebal last time, boron, beryllium, aluminium. Okay, these three species has a vacant orbital. How about B? B, CO3+. Kalau tak ingat NH3 ni dia ada lone pair, maybe this is more obvious than this one kan. This is positive cation. So it has less electron, lack of electron. So this is Lewis acid. This is Lewis base. Okay, that's all. Ni tak payah worry on this one. Done. Okay, so that is all for today, guys. So the following we will continue tomorrow. Okay, so any question? Ada? If there is no question, I think that is all. So thank you everyone for your attention. Assalamualaikum.